Okay, so this is going to be exercise 40, which is to be found on page 34. What do we have? Well, we have, on the one hand, we have a line given by y equals 8 times x. On the other hand, we have a function given by the equation y equals square root of 2 minus 8 times x. And here you see from the very beginning a is assumed to be positive. This will become important in the very last step of this exercise. Okay, so our problem is, well, of course, finding the value of a. So this exercise is still about finding a function equation. Okay, so what do we have? Well, first thing to note is this line L here. That's a straight line, of course. And according to the exercise, that straight line stands perpendicular on the graph of f. So the straight line intersects the graph of f in a right angle. So maybe to start, it's a good idea to draw a picture of the situation. Well, here, of course, you can't use your calculator to draw the graph of this thing here because of the a, of course. However, just take any positive value of a, let's say a equals 2, and draw the graph, and then you will see how the graph of f looks like, more or less. Okay, so you will see f looks somewhat like this. In addition, we have this line here, and of course this is a straight line passing through the origin, so like this. That's L. And now this line intersects the graph of f under a right angle. Well, what does this mean? This means if we add the tangent here, then the tangent and L enclose a right angle. So L and T enclose a right angle, or what is precisely the same thing, L is a normal to the curve of f. That's precisely the same thing. Okay, so what do we have? Well, we have here a right angle. So let's see. Here we have a point. Let's call that point P. And the x-coordinate of that point we are going to call x0. So, well, what do we have? We have, there's a point x0 such that the tangent t in x0 is perpendicular to L. Okay, so that's the thing. Now, t is a tangent, so a straight line, so the function equation looks like this: y equals m times x plus q. And now this is the most important part of the whole exercise. We are going to consider this m here. This is the slope of the tangent. And the point is, we know several things about the slope. So what do we know about m? And the important thing is we know not only one thing, we know two things. First of all, m is the slope of the tangent, and the slope of the tangent is given by the derivative. So f prime of x0 equals m. That's just that notion of a derivative. That's the definition. So at this moment, this should no longer be any surprise. So, but however, now maybe the more important part is, well, m is also equal to minus 1 over a. Why is this the case? Well, don't forget our formula. The slope of the tangent equals minus 1 over the slope of the normal. And that's precisely what we are using here, because the slope of the normal is a. So the slope of the tangent is given by this. So this thing here is due to the fact that L stands perpendicular on T. Together we have these two things, and well, this is M and this is M, so we can set these two things equal, and this leads to the most important equation of the whole exercise. F prime of x0 equals minus 1 over a. And basically, well, that's not yet completely everything, but that's the important step. So we take the derivative, f prime of x0, and now, well, this is a square root function, and well, you should be familiar with taking the derivatives of these functions. That's 1 over 2 times square root of 2 minus a times x0 times the derivative of what is under the square root, which is in this case just minus a. Taking this here on the fraction line just to simplify a bit, leading to this thing here. Okay, so this is my, and this of course is equal to minus 1 over a, and this thing here is my first equation. The problem now is here. You see, well, this is almost good, but not completely. Why? The problem is we have not only a, which is unknown, we have also x0, and x0 is also unknown. So in this one single equation, we have two unknowns, so we must try to eliminate one of them. Okay? There's one thing we haven't used. Okay? Namely the fact that point P lies on, well, that's a point of intersection, right? So it lies on L and on the curve of F. Right, it lies on both these two things. So since the point lies on L, we can find the y coordinate, right? So from this it follows that P has coordinates x0, a times x0. Moreover, this point lies on the curve of f, which means the coordinates of that point satisfy the function equation. So a times x0 equals square root of 2 minus a times x0. Just here eliminating the square root just in order to simplify a bit. Squaring both sides leads to this. And this now is my second equation. And basically now we are done. What remains is pure algebra. So we have this equation here containing two unknowns. We have this equation here containing two unknowns. So we are going to solve this system of equations. Well, there are several ways to do that. I'm just going to show you one. Okay. So I'm going to start with equation 1. So from 1. Well, what was 1? This was my equation 1. And now, well, the first step should be clear. I eliminate the fractions because I don't like fractions. That's why I'm getting rid of them. Moreover, here you see we have a minus on both sides, which means we can cancel that on both sides. So a goes there, this goes there. That's called cross multiplying, right? So this is this. Okay, now next thing I want to get rid of is I want to eliminate the square root, which means I'm going to square the whole equation, right? Squaring a squared leads to a to the power of 4, and here don't forget to square this 2 as well. That needs to be squared, and here there needs to be a bracket around it because this square root works as a bracket as well. So we have this. And now, well, what am I doing with this? Well, I'm going to solve for x0, right? So first thing, I eliminate here the brackets. I take this on the other side and this on the other side, which leads to this. And now I divide by 4 times a, leading to this. Sorry, 4 times a. Okay, that's not bad, because this one here is solved for one of the two unknowns. So I'm going to take this and I'm going to plug it into 2. So plugging this into 2 leads to, well, leads to this equation, and the only thing left to do is to take this equation and solve for a, and then we're done. So here you see first we are squaring a product, which means I can square both factors in isolation. Moreover, here we are squaring a fraction, which means I can square the upper part and the lower part, leading to 4a squared is 16a squared. Here I'm not doing anything at the moment, just leaving it the way it is. Now consider this thing here. First, you have here an a squared and here an a squared, which means you can reduce. Here you have an a and there an a, so there you can reduce as well, leading to this squared. Okay, now I'm going to eliminate the fractions, multiplying everything with 16. Here I need to multiply with 4. Okay, now eliminating the brackets here. I'm not going to simplify this, you will see why in a few seconds. Okay, so this drops out. And now, this is the idea here, I can take the square root of both sides. Just this one here goes away. And on this side, I'm going to take the square root, which leads to this. Okay, and now I have a very simple equation. I'm going to take everything on one side. Which leads to this, and now I'm done. I can take my calculator and solve for a here, and well, you need to write this, of course, in a first step like this. Okay, now you can take your calculator and solve for a, which leads to a equals plus minus square root of 2, and now since a is assumed to be positive from the very beginning, we can ignore the negative solution, leading to a equals square root of 2. And that's the whole exercise. Thanks for watching. I know that wasn't an easy thing.